Good evening, everybody, and once again, welcome back to the video. This is gonna be a little long video and a very informative video, so stay tuned till the end of the video. So in today's video, we are gonna talk about dynamic hoodie DeltaStreamer jobs with JDBC Puller for Postgres table, bringing all tables into hoodie and running jobs in parallel. So just a little background before we go deep inside this lab, right? So far we had 14 or 13 labs in Hoodie DeltaStreamer. We learned about everything about Hoodie DeltaStreamer, how to ingest data from CSV, Parquet, Kafka, etc., etc. Now what I want to show you is, I want to basically start with a question here and then we'll dive into the solution, of course, is this. Now in the Postgres, let's say you have 100 tables. Are you gonna create Spark submit jobs manually for all the 50? Would take months, right? Would you create all these configs manually? It's gonna take a long time, right? Well, then what do we do? Well, what we can do is with this approach. So basically, we can write a config.yml file. Inside the config.yml, we're gonna define the schema and we're gonna say, hey, I want to bring all the tables from this particular schema, okay? All right, now what we're gonna do is we're gonna write a Python automation script, and this script, what it does, first it will start and then it's gonna fetch all the list of tables from a particular schema. Then for each table, we are gonna create a trigger, meaning anytime there's any insert, anytime there's any update, automatically the timestamp column is updated. So that's called a trigger. So it's gonna create a trigger. So first we're gonna check if the trigger exists. If the trigger exists, we are not gonna create the trigger. But if it does not exist, we're gonna create the trigger. After that, we're gonna fetch the primary key of that particular table, and then we're gonna set the record key to the primary key of the table. Okay, and the dedupe key becomes your updated at. And for all the tables, we're gonna basically partition by a year and a month. It's a bronze layer and it works perfectly fine. So now that you have a clear picture of what we are talking about in this video, so now let's dive deep into that. All right. So I'm gonna now share my screen and we'll perform this lab. So the first step is we would need a Postgres database and we can use Docker to spin that up. So I've given you a file called dockercompose.yml, and inside there's an image. If you're using a Mac OS, you can use ARM64 v8 Docker image, but if you're using Windows, just use Postgres 13. Okay, so I've commented out the Windows code part. Now, if you come into the project directory, all you gotta do is say docker compose up and this should start up your Postgres container. So now that you have your Postgres, we need some tables, right? Now this could be 5, 6, 10, 50, 30, how much ever you want, right? I have a Python file which is called generate_table.py. Simply put the number of tables that you are interested and this will generate those tables into Postgres. So now what we will do, we're gonna run the Python file, Python generate_tables.py. So as soon as I create or run this file, this will generate the number of tables that you have specified with some data. So if I now go and if I run here quickly, let me just connect. And here you can see, I see some data. Again, all it has an ID, a column data, and and a column called updated at. The column updated at is very important because now we're gonna use this in the next process, okay? So step 2 is very simple. Just run the Python file. This will generate the number of tables into the public schema. So now that we have some tables, now we need to define a config.yml file. Now, in general, the goal is to provide your common settings or some stuff into config.yml file. That's the general idea that I want to pitch here. So over here, I put the username, password, host, database name, port. Now what is this threads? So again, when we are gonna create the DeltaStreamer Spark submit job, right? How many Spark submit job you wanna run in parallel, right? So number 2 suggests that I wanna have the thread of the processes 2 set to 2, okay? Schema is public, which means I wanna bring all the tables from the schema public. Target base path, this is the path where my Hoodie transactional data lake will be created. Now, this is the base path. So whatever tables we are on, so let's say table A, so it's gonna create the path as the base path plus the table A, base path plus table B. Hopefully you guys got the idea, right? Then we provide the location of the jar, skip table, right? Now, inside the schema public, there might be a lot of tables, right? 50, 100, doesn't really matter, right? There might be few tables that you might not want to bring, right? So those are the tables that you can specify here by a comma separated value, okay? So hopefully that made sense. And then here, just some basic settings like packages and table type and operation. So step 3 in config.yml, we define our configuration, right? Now let's discuss the main part, which is over here, which is master.py, as mentioned on the article over here. So I'm gonna collapse this and I'm gonna probably go to the main function, and let me adjust my screen a little bit so you guys can see much better. All right, hopefully you guys can see my screen, right? Okay, so again, I'm gonna repeat the steps. So the goal or the idea is I want to fetch all the particular table names inside that particular schema. Once I have all the table name, then for each table, I want to check if the current table that I'm working on, is that the table that the user has specified that he or she wants to skip. If it is, I don't want to ingest that table, right? Hopefully made sense, right? So now we're going to see all this in code. Again, on my article, you know, if you're gonna read, I have this flow chart, right, which basically explains, right. So as you can see, we load all the configuration from the YML, right. We fetch all the tables, right, and then what we do is for each table, we make sure that the table is not in the skip table. If that is the case, then we come inside and say, hey, for that particular table, is there a trigger? Which means anytime anything insert update happens, you know, that particular column called updated at, it will basically update the timestamp for that particular row, right? Hopefully made sense. So if the trigger exists, great. If it does not exist, you want to create one, as you can see over here on my mouse, hopefully, right? If the trigger exists, then you basically fetch the primary key, right? So we want to fetch the primary key of the table that we are ingesting, and then what we do is we set the record key to the primary key, okay? And the dedupe key, which is precom key, is set to updated at, which is again a timestamp, right? Now for all these tables, right, this is a bronze layer, right? I want to partition my data by a year and a month. So we have that timestamp column in all the tables, right? So what it will do is we are going to use a SQL based transformer to extract the year, to extract the month, and then all these tables will follow a similar fashion. Hopefully made sense, right? So again, the flowchart here is given, okay? So the code, you know, just does that. As you can see, we create a connector object. Again, it's a lot of code again, but I just, you know, walking you over that, right? So for each table, as you can see over here, for each table, you know, then we check if the table is in the skip table. If it is in the skip table, pass. Then we come inside. This is the else part. Check if the trigger exists, as you can see here. If the trigger exists, you know, do not create one, fetch the primary key. If it does not exist, create the trigger, fetch the primary key. And at the end, what you would see here is we have a function called generate spark submit job. So this is the function which will generate the spark submit job. And as you can see, we have a couple of placeholder here, right? Which means from the config or the table that we are working on, those values are going to be injected. Now, once we create the spark submit job, now here is how it works, right? We have an array declared right on the top of the for loop, which means for each table over here, as you can see, for each table, we generate the spark submit job and then we append that spark submit job to the array. Now, at the end of the for loop, I have all the spark submit jobs in an array. Now I can use thread pull object and launch all of them in parallel, right? Hopefully made sense. So here, with concurrent.futures.thread pull executor, you define the number of workers. And the number of workers again comes from the config file, right? Which is set to 2 here. And then basically we start the spark submit job. So hopefully all of this made sense. Now, hey, Saumil, show me things in action. So now let's run everything, okay? All right, so now I'll be running everything, okay? So I'm in that project directory. So again, I have my triggers and everything in place. So as you can see over here, I have all these tables. So let me just refresh. I have 3 tables again, but you can have 30, 40, 60. In that Python script, you can specify that, right? All right, so now what we want to do is we're gonna run the Python file master.py. In my computer, I've named it as p3, but it will be master.py probably. All right, so now observe here. Python. And again, before that, I do not have any hoodie tables in this directory. Okay, so okay, come here. Okay, Python 3 p3.py, and once I run, you will see everything in action. Okay, so here you can see it did generate the Spark Submit job, and now it's executing multiple Spark Submit job in parallel. So now, the JDBC based incremental puller is ingesting data from all these Postgres table 1, table 2, table 3, as you can see, and at the end it will basically print a report. Hopefully you'll see what I'm saying. So again, yeah, as you can see, right? Yeah, complete, right? So now, as you can see over here, this was the table name, tables, right? These are the table name in Postgres. This is the schema. This is the primary key in each particular table, and trigger. As you can see, the trigger is created, because when you're running for the first time, these triggers are not going to be there. So you're basically setting up this trigger, which basically makes sense, right? If I run again, right, Python p3.py, these triggers are not going to be created because they already exist, right? So it's taken care in the code itself. So again, this is running all the DeltaStreamer commands. As you can see, trigger exists, trigger exists, trigger exists, right? Now if we go here, right, as you can see, hoodie db, table 1, table 2, table 3, right? Hopefully if you guys can see, if not, let me just open that in the Finder. Right, table 1, and again year, month, and then you have your day, and then the Parquet file, and then you have all the tables, right? So what you want to take from this video is the approach, right? The concept, right? So let's say you have n number of tables. What you want to do is push your basic configuration into some sort of a YAML or a JSON file. And then you want to write a Python template to generate the Spark Submit command dynamically, and then basically you're going to submit that, right? Just the way I showed. So what I would want to say to you is feel free to try these labs out. Take some time, pause the video, go to the source code, read the code. On LinkedIn as well, I have broken down into steps, right? So hopefully should be an easy process to follow. Now the same process goes with Kafka source, right? Now you have multiple topics, right? And you want to basically ingest, let's say you want to ingest data from, let's say 30, 40, 60, 100 topics, right? You're not going to write configuration manually, right? Excuse me, you're not going to write it manually, right? What you want to do is you want to automate it. You want to write a script which takes these parameters and generates the Spark Submit or these files, and then basically does the Spark Submit, right? Hopefully made sense. I'll conclude the video right here. Hopefully you got the big picture here. Hopefully you got the concept. Hopefully you got the idea. I demonstrated for Postgres, but this could be extended to any other databases or source as well. Thank you so much for watching. Keep smiling, keep programming, and I'll see you in the next video.